Okay, so let's suppose we have the following situation. We have risk aversion at a level of 2.5. Utility is going to be 7%, 8%, 9%, and then we're going to have another number over here to the side we'll deal with in a minute, of 0.0944. Okay. So we'll have different standard deviations. We'll have these first order indifference curves. And then a tangent line. So go from 0 to 15%. And for indifference curves, the formula we're going to have here is expected utility plus 1/2 a times the standard deviation squared. So for this will be equal to the following formula. Equal B2 anchored to just B dollar sign 2 plus 0.5 times B1 anchored times A4 caret 2 and the A in front of the A4 needs to be dollar sign anchored. So now I drag this across and then double click, send it down. So you should have 7% all the way to 11.81% for various indifference curves. The tangent line formula, or for the tangent curve, is equal to A2, just anchoring the dollar sign, B dollar sign 2, plus 0.5 times B1 anchored plus dollar sign A4 caret 2. Let me double check. So for the B dollar sign 2, that should be E dollar sign 2 plus 0.5 B1 is the risk aversion plus dollar sign A4 standard deviation caret 2. Okay. It still is not giving me. This, instead of plus should be times. There we go. Okay. So now we'll have three curves that we'll draw. The standard deviation, this and these are expected returns that we've calculated here. So if I insert this, recommend charts. So those are all the indifference curves and the tangent, maybe potentially to, if your optimal portfolio gave you utility 9.44%. But you do use these indifference curves and how it touches the market portfolio, because recall market portfolios like this shape. So I'll draw real quick. So essentially what would happen is this would be your efficient frontier, and wherever you could get to the highest difference curve, such that maybe this one where it's tangent, that would be your optimal portfolio. Okay. One other quick note to demonstrate this you go back, um, so given this particular data, if I wanted to calculate utility, that's going to be equal to we said this was the expected utility plus, and then go back. This will be 0.5 times the expected return times the standard deviation carrot 2. So that way you're giving utility for the various formulas. And let's see, so this part will be anchored. And there we go. So you want to pick the portfolio with highest utility.